Okay, let's just jump right into one of the most mind-bending ideas in all of cosmology. What if our entire universe exists inside a black hole? And what if that's not just some random fluke, but the result of a cosmic evolutionary cycle, a process of birth and reproduction that could actually explain why we're here at all? It's a wild ride for sure, but it puts forward a really powerful answer to a very, very big question. And that question is this: why are the rules of our universe so perfect? I mean, so exquisitely fine-tuned for things to exist. It's a puzzle that has kept physicists up at night for decades. It's almost as if someone, or something, set all the dials just right. You see, if you change the fundamental constants, like the strength of gravity or the mass of an electron, even by the tiniest fraction, the universe as we know it just vanishes. No stars, no planets, no us. So, did we just win an unbelievable cosmic lottery? Or is there something deeper, something more logical going on here? To explore that deeper principle, we have to look at the most destructive objects we can imagine, black holes. But this theory argues that we've only got half the story. What if they aren't just cosmic vacuum cleaners? What if they're actually cosmic wombs? Okay, this is where your intuition gets flipped completely upside down. We all think of black holes as these hyperdense, crushed little points. And for the small ones, that's kind of true. But the math shows something pretty amazing. As a black hole gets bigger and bigger, its average density actually plummets. Get this, a black hole with a mass of billions of suns, one big enough to swallow our entire solar system, would have an average density about the same as the air in this room. Seriously, all of a sudden the idea of a whole universe existing inside one doesn't sound so violent or crazy, does it? In fact, our own universe has an average density that could technically form a black hole way bigger than itself. So, if a universe can act like a black hole, could a black hole become a universe? This is where our understanding of space and time gets completely twisted, leading to something called a big bounce, hidden deep inside. Now, to get this, you have to understand what a singularity really is. It's not a tiny point in the center that you travel towards. Nope. The moment you cross the event horizon, space and time literally trade places. The singularity is no longer a where, it's a when. It becomes an unavoidable moment in your future, just like next Tuesday is for us. The entire space inside the black hole is hurtling towards that final moment. So once you're inside, time is running out. All of space itself starts to contract, squeezing everything towards that final moment. It's basically a big crunch. But according to this theory, that final collapse doesn't just end. Just like a rubber ball you squeeze, it rebounds. It bounces back, exploding into a new Big Bang, creating a brand new universe. And here's the wildest part. From our perspective, outside that black hole, nothing would look any different. It would just sit there. We would have absolutely no way of knowing that an entire cosmos with its own galaxies and stars just burst into existence inside it. This idea of cosmic reproduction through black holes, well, it builds into an incredible theory, opening the door to a truly mind-boggling concept, cosmological natural selection. It works just like biological evolution. Think of each big bounce as a birth. But the process isn't a perfect copy. The physical laws of the new daughter universe might be slightly different from its parent. Now, some of these new universes might get a bad roll with the dice. Their physics prevents stars and black holes from ever forming. They can't reproduce, so their line just dies out. But other universes, they might have laws that are fantastic at making black holes, and they'll go on to have lots and lots of offspring. The logic is pretty tough to argue with. Over countless cosmic generations, the universes that become the most common, the ones that dominate the cosmic landscape, are going to be the ones whose physics is optimized for making the most black holes. It's survival of the fittest, but on a cosmic scale. And this is what brings us right back to our original mystery. What does a universe that's optimized to make black holes actually look like? Well, it looks a whole lot like ours. I mean, think about it. To make a ton of black holes, what ingredients do you need? You need physics that lets you form huge galaxies. And those galaxies have to be filled with billions of massive stars that can live, die, and collapse. And, well, our universe is exceptionally good at doing exactly that. And this is the beautiful, almost poetic conclusion of the whole argument. The very same conditions that make a universe great for producing black holes, galaxies, stars, stable chemistry, long lifespans, are also the exact same conditions needed for life to emerge. In this theory, life isn't the goal of cosmic evolution, it's just this stunning, incredible side effect of a universe that's simply built to reproduce itself. So it leaves us with this pretty profound thought. Maybe the reason our universe seems so perfectly made for us is because we're living in a long, long line of cosmic winners, universes that mastered the art of making more universes. And if that's true, our existence isn't a fluke at all. It might just be a predictable outcome of the universe's ultimate drive to create.